So in a science experiment, students punched a hole near the bottom of a 2-liter pop bottle. They filled the bottle with water and measured how the water level changed over time. The results are shown in the table below. So we have time, and then we have the water level, and then you have to decide which one is the independent and which one is the dependent. Usually the time is our independent variable, but think about it this way. The water level depends on how long the hole has been, poked in the bottle, right? So that level depends on the time. So time is our independent because time is not going to get affected by the water level, but the water level is going to get affected by the time. So your question is asking you to use the graphing technology to perform linear, quadratic, and exponential regression on the data. Okay? So basically all what we have to do right now is plug in these values in Excel, and we're going to have to find the regression line. So I have my data here. All what we have to do is we have to insert and a scatter plot. Bless you. And then we see this, right? Looking at it, it could be linear, it could be quadratic, half of it. It could be an exponential, right? It could be either of the three. So what we're gonna do, we're gonna graph 3 graphs here, okay? So this is the first one, and then we're gonna do a linear regression for this one. So right click, add trend line, and then we're gonna pick the linear regression, and we're gonna say display equation and display the R squared value. So this is our first regression line. So this is a linear one. We see that the R squared is 0.9778, which is pretty high. Now we're gonna do the same thing. So we're gonna graph another graph, and then we are going to choose a different regression line now. So we're gonna go, highlight this again, and then insert, scatter plot. So this is another graph, right? It's the same graph, but now I'm picking a different regression line. So add trend line, and then we're gonna go to the polynomial with an order of 2. Remember, polynomial order 2, that means quadratic. Again, display equation and display R squared. What do you notice here? What's the R squared value?
1.
Can I get anything higher than 1 on the R squared? That's a perfect match. You see that? The line is perfectly matching with the points. You see how it's like the line is going through each and every point?
Yeah.
Now, but the question is asking me to do all 3 regression lines. So I have to graph the third one as well, even though I probably found my answer, but I have to find the third one. And again, add trend line. And we're gonna pick the exponential, and then we're gonna ask it to find the R squared value. So you see here that I have the 3 R's, the 3 equations, right? And looking at all 3 of them, it seems like this one is my perfect match, right? R squared equals to 1. So this is how and why I'm deciding that it is actually a quadratic fit and not any of the other 2, because my R squared value is a higher value for the quadratic. Okay? So what we're going to do, what you can do when this happens, remember that you have to include title for me and everything. So, oops. I don't want to. Let me erase this. Okay, so basically you're going to have to make sure that you include a chart title, don't forget that, and the axis title. So this is going to be time in seconds and This is going to be
Lower level in centimeters.
and what would be a good chart title for this?
Science experiment. No.
Water level in a science experiment. Sure. The thing, the chart title should be just an indicative, so when I look at it, I kind of understand what it is, but at the same time I can refer to the question. Okay, so I know that this talks about that specific question. Okay, and that's gonna have to be done for all three charts, right? Where you have to include the time, you have to include the axis title and the chart title. Are you guys okay with this?
Yeah.
Okay, so I'm gonna go back here, and then we're gonna have to, let me see if I can actually copy all of these three. I'm just trying to copy them all on my sheet. All right. So which model best presents the data? Justify your answer. So we're gonna say that the linear model is the worst fit because it has the lowest R² value. We're gonna say the quadratic model is the best fit because it has the perfect R² value. And then exponential is okay. Exponential models are okay, but we're gonna pick the quadratic because it has the perfect fit. Now also you have to think about this, right? I pick quadratic, but I have to have a restriction on the quadratic, right? Because usually quadratic, if I look at this quadratic, right? It's gonna have, quadratic says that it has to go back up. Is the water level gonna go back up?
No.
And that, so it's not. So when you're looking at your risk, you're looking at your x values, you're gonna have to pick a restriction that the x value cannot go anytime after a certain time, where you're gonna have a little bit of water left in your bottle, but they're not gonna drain because they're below the hole, right? And then they're gonna stay there. Okay? So there's always restriction that we have to think about in these type of questions.
Is it like x's cannot be equal to like, or?
Yeah,
above
x has to be like less than or equal to a certain point.
30, like, right? Because that's.
It's gonna have to be like 100, right? In this case, I don't know if they took any values below the 6 or below the 7 or whatever that value is, but the x basically cannot be higher than 100, it has to be lower than 100. So basically what we say that it's between 0 and
Yeah.
100, let's say, okay? But, again, we don't have to do that in this course, but in other courses you're gonna have to look at domain